Welcome to homework.
So this is problem 24.55. In this problem, we have a piece of glass which has a refractive index 1.56, and on top of this piece of glass, we have a thin film of alcohol which has a refractive index of 1.36. And we observed that for a wavelength of 525 nanometers, the intensity of the reflected beam was the minimum, and for a wavelength that is 655 nanometers, the intensity of the reflected beam was maximum. And the question is asking what should be the thickness of that alcohol film so that we will have this better. Okay, so that's the thickness is what we are solving for. So the first thing is to consider here is actually what will happen to the light ray when going through these interfaces. So when the light ray is coming from here, okay, so it's coming from a lower refractive index to a higher refractive index, so it will actually suffer from a change of phase by 180 degrees. And the transmitted beam here actually, again, it's going from a lower refractive index to a higher refractive index, so it will suffer from another 180 degrees change of phase. So actually, these two reflective beams will have the same phase. And so the condition for dark or lower intensity would be that the path difference, which is twice the thickness of the thin film, would be half an integer times lambda, right? While the condition for bright, which is the maximum intensity, will be that the path difference, which is twice the thickness, will be some integer times lambda. But actually, because lambda will change here inside the medium, so these two lambdas are not these lambdas, they should be lambda over n for both of them, right? Okay, so t should be, you can get 2 outside here, so it should be n plus half times lambda minimum over 2n, and it also should be some other integer times lambda maximum over 2n. So we can get these two ratios, lambda minimum over 2n, which is 525 nanometers over 2n, which is 2 times 1.36, and this will give us 193 nanometers, while the other ratio here, lambda max over 2n, will be 655 nanometers over 2 times 1.36, which will give us 240.9 nanometers. And so we know that the thickness should be an integer and a half times this value, and at the same time an integer times this value. And if we try the integers, we will find out that actually t, the minimum t, okay, is 483 nanometers, which is twice this value, 2 times this, and at the same time 2.5 as this. So it actually satisfies both of these two conditions. That's why, and there are a lot of other t's that satisfy these two conditions, but this is like the minimum t that satisfy this condition.